Hi, this is Felix Biesmann, and I will be talking about some work that I've been doing together with Dion, my master student. And we were comparing quality metrics for transparent machine learning with and without humans in the loop. And well, we found that these two metrics are not necessarily correlated. So why do we do interpretability? I think there is consensus amongst researchers that machine learning models require some explanations to foster trust and to debug models. There are a variety of reasons why we should do this. And many explainable artificial intelligence XAI approaches were proposed. But when I started looking into the field, I was really puzzled by the wealth of methods out there, and I wasn't really sure which approach is best for a given application. So the questions we were trying to address here is how to select XAI methods for a given application, and also if you want to build a new XAI method, how should you optimize that for which metric? That's the underlying research question here. So there are many different aspects of what makes a good explanation, and there is not one quality metric that would work for all aspects of quality of an explanation. One dimension along which these quality metrics can be differentiated is that of how much human intervention is needed to compute them. So there are, and this is probably more standard, there are methods without humans in the loop where you would just basically, for instance, measure how well the features that were considered important by some saliency map or by some explanation method, how well these features that were top ranked in an explanation help to predict a certain label, for instance. And these approaches without humans in the loop are scalable, but they are just a proxy for how well humans understand an explanation. And ultimately, explanations cannot be defined without humans. Epistemologically, an explanation it implies that there is a human observer that can understand something, or at least some sort of intelligent being. We don't explain things to chairs or computers. So that's why these human in the loop quality metrics have become more important recently. They're not very scalable, but people try to use crowdsourcing approaches to make them scalable. And these approaches measure directly how much an explanation helps to understand, for instance, machine learning predictions when looking at simulatability, for instance, or at annotation efficiency in labeling tasks. So we were interested in how these two approaches compare. So the research question here was, are explainable AI metrics with and without humans in the loop correlated? Can we learn something about one metric from the other metric? And the experiment we ran was we used the standard computer vision task, recognition of emotion on human faces, and we masked the pixels according to their feature importance. And the feature importance was computed with different XAI methods. And the assumption was that if one of these methods is better than another, then the top ranked pixels features would be more informative for both machines and humans. So we did this evaluation similarly for humans and machines. The machine-based evaluation is pretty similar to what people used in evaluations of saliency maps. And the human evaluation is pretty similar to what people have done in psychophysics. So this is how one example looked like. So here we have a face, and it's pretty clear that here this is a happy face, and we just looked at happy and angry, these two classes from the data set. And we also offered the option, I don't know, if somebody didn't know what emotion was shown. And so that was the experiment. And these are the results. So to well, the paper shows a lot more results, but this is, I think, the most important results. We look here at the machine-based evaluations when well, unmasking the pixels, unmasking the images progressively, and we here look at the averaged rank of 3 different saliency methods. We don't see any clear winner here. That's the main takeaway. So none of these, either layer-wise relevance propagation or just plain gradient or guided backprop, provides better explanations as measured by this metric, whether the machine learning model predicts the right class given an image where not all pixels were shown. And if we compare that with human performance, the result looks very different. So when we ask humans to predict the emotion with these masked images, we find that one of these methods, the gradient method, well, appears to be worse than the others. Guided backprop appears to be best. And here the ranks, yeah, there are, so higher ranks are better here. That's a bit counterintuitive. So we see that guided backprop consistently outperforms the other explanation methods. So the main takeaways here are humans find one type of explanation consistently better and another type of explanation consistently worse for, annotating these images with emotions, with the emotion label. And so, and this is different for machine-based, no human in the loop metrics, essentially. So these two provide different results and they are not correlated. And that's already the conclusion. So we all know that interpretability is difficult to measure and there is no one single metric that would serve all purposes. But what our experiments showed is that metrics without humans in the loop, which became sort of standard for evaluating such methods, they are not correlated with explanation quality as perceived by humans. Thanks a lot.